We're back with another limit problem. So we want to compute the limit as x approaches infinity of the square root of x squared plus 6x minus x. So when we are evaluating limits, the first thing we always do is we plug in whatever value we are approaching. Now, because infinity is not finite, in other words, it's not a real number, it doesn't really make sense to say plug in infinity. So we're just going to look at this piece by piece. As x approaches infinity, the square root of x squared plus 6x is going to grow without bound. In other words, it's going to go off to infinity. And then x is going to keep getting larger and larger. So that's going to go off to infinity. So what we have is infinity minus infinity, which is an indeterminate form. So we need to do more work in order to figure out what the answer is, because the answer could be anything at this point. So let's start over. So we're going to have the limit as x approaches infinity of the square root of x squared plus 6x minus x. All right. Now, the key to solving this limit problem is to multiply by the conjugate of this expression that we have here. So I'm going to multiply the square root of x squared plus 6x by I'm going to multiply the square root of x squared plus 6x minus x by the square root of x squared plus 6x plus x. And then what I do to the numerator, I must do to the denominator as well. Remember, when you multiply by the conjugate, you're pretty much just copy and pasting the original expression you have, except for you're turning this minus sign into a plus sign, or if you originally have a plus sign here, you're turning that plus sign into a minus sign now. So what happens now is upstairs in the numerator, you have a difference of squares. So these radicals will disappear, and we can copy and paste what's under the radicals. So we'll have x squared plus 6x, and then we'll have negative x times x, which is negative x squared, all divided by the square root of x squared plus 6x, and then plus x. All right. I see an x squared and a negative x squared, so let's make those disappear. And now if we try to plug in, and I'm being a bit loose with what I'm saying right now, if we try to plug in infinity everywhere we see an x, it's not quite clear what our answer is, okay? So here is how we're going to go about solving this limit. We are going to work with this expression that's under the radical first, and we're going to factor out x squared. So we're going to have square root of x squared times 1 plus 6 over x. All right, so that's what happens when we factor out x squared. And let's just remind ourselves of some things. The square root of a times b equals the square root of a times the square root of b, provided that a and b are both non-negative. And the square root of x squared equals the absolute value of x. Now, in this case, because our x's are positive, we're approaching positive infinity, right? This implies, in this case, that the square root of x squared is just simply going to be x, all right? If we were going off to negative infinity, then this would have to be a negative x, so we would have to put a negative in front of here, but because our x's are approaching positive infinity, this implies the square root of x squared is going to equal x. So we're going to use these two facts to help us solve this limit. So upstairs in the numerator, we still have 6x divided by, now we're going to have the square root of x squared times the square root of 1 plus 6 divided by x. And then we have this extra x dangling out there. Now, we know this piece, the square root of x squared, is going to equal x in this case. So here's what I'm going to do. I'm just going to cross this out and turn it into an x. And now what we're going to do is we're going to factor out a common factor of x in the numerator, or excuse me, in the denominator. So we're going to have 6x divided by x times the square root of 1 plus 6 divided by x plus 1. And now we can go ahead and cancel those x's, and what we will have is the limit as x approaches infinity of 6 divided by the square root of 1 plus 6 divided by x, and then plus 1. All right, so now we can go ahead and plug in infinity, again, being very loose, and see what happens as our x values get really, really large. So we know in the numerator, we just have a constant of 6, so that can stay up there. Down here in the denominator, we have the square root of 1 plus 6 divided by x. This piece is going to go to 0 because you have a fixed numerator and a denominator that grows without bounds. So what's going to happen is you're going to approach 0 through positive values. So we're going to have 6 divided by the square root of 1. We copy and paste the other constant with us. So 6 divided by the square root of 1 plus 1, which is equal to 6 divided by 2, which is 3. And that is the answer for our limit.